Hello, I'm Tana, your MLC tutor. Okay, I had a viewer request that I attempt this problem. He says that under deMoivre's law, the probability of a 98-year-old dying before an 80-year-old is 4/5, or 0.8. Both lives are independent, and what is omega, or the limiting age? So, okay, under deMoivre's law, so that means that the future lifetimes of this 98-year-old and the 80-year-old follow deMoivre's law, or are uniformly distributed. So for the 98-year-old, their future lifetime will be uniformly distributed on 0 to omega, or the limiting age, minus 98, because 0 is the shortest amount of time they could live, and the length of this interval, or omega minus 98, is the longest amount of time they could live. Similarly, for the 80-year-old, their future remaining lifetime will be uniformly distributed on 0 to omega minus 80. And we want to know the probability that the 98-year-old dies first. Or in other words, we can write this as, let's see, I guess I don't even know exactly what would be the best way to say this, but so Q80 semicolon 98, the little one above it, just in case you can't see it, and then an infinity out to the left. And this is going to mean you have an 80-year-old and 98-year-old. Of course, both of the future remaining lifetimes are independent. This is the probability that the 98-year-old dies first, but not by any specific point in the future, just at any time. Of course, it's limited by omega, the limiting age. So let's think about all the possible ways that this could happen or be true. So the 98-year-old dies before the 80-year-old. So that's going to happen at some point t. We don't know when, but the 80-year-old will live at least to that point t, which is TP80. And the 98-year-old will die at that point t. We can represent that with the probability density function for the future lifetime of the 98-year-old evaluated at t. If this doesn't make sense, this is like, okay, the probability that the 98-year-old dies at t is the probability that their future lifetime equals t. This future lifetime is a random variable. If we want to know the probability that a random variable takes on some value, here t, we're going to look at their probability density function evaluated at t, at that value. So same thing here. We want to know the probability that the future remaining lifetime for the 98-year-old is t, so we're looking at the probability density function of the future lifetime of the 98-year-old evaluated at t. Okay? But this can happen at a lot of different times t. More specifically, it can happen at any time from 0 to, as long as the 98-year-old can live, because after the 98-year-old dies, we're looking for the probability, we're looking for the probability that the 98-year-old dies before 80. So once we reach that 98-year-old's limiting age, the 98-year-old is certainly dead, and we're sort of done. So we're going to integrate this over all the possible values that t can take on. So 0 to omega minus 98, because that's the longest that the 98-year-old can live. And of course, we're integrating with respect to t. So let's start with TP80. We know that since the future lifetime of the 80-year-old follows a uniform distribution, this is going to be omega minus 80 minus t over omega minus 80. And if that doesn't make sense to you intuitively, not just memorizing it, I do have a video on the deMoivre distribution and how to find certain probabilities associated with it, so check that out. And then the probability density function for the 98-year-old Again, because it follows a uniform distribution, it's going to be 1 over the length of the interval, which is omega minus 98. And you're integrating that with respect to t. So I will go through the whole integration. I'm sure you're comfortable doing that. But when you solve for omega, you should get 110. If you have any questions on that, or even if you'd like me to go through the integration, please let me know and I would be happy to. Happy studying.